Let's look at this homework problem from chapter 10. It's number 30. Please remember what you see on your homework might have different numbers. So it says, listed below are systolic blood pressure measurements in milligrams in mmHg obtained from the same woman. Find the regression equation, letting the right arm blood pressure be the predictor X variable. Find the best predicted systolic blood pressure in the left arm, given that the systolic blood pressure in the right arm is 90 mmHg. Use a significance level of 0.05. So the first thing I'm going to do is put this data in my calculator. So I'm going to hit the Stat button, and I'm going to hit Edit. And I'm going to clear out List 1, and I'm going to clear out List 2. Then in List 1, I'm going to enter my X values, so the right arm values. So I have 101, 100, 93, 79, and 79. In L2, I'll put the Y values, so that would be the left arm values. 175, 169, 145, 146, and 144. Now what I'm going to do is hit Stat, Tests, and I am going to do this option F, the Lin-Reg t-test. Now, because I'm using a free version of the calculator, it's going to look a little bit different than what it will on your TI 83 or 84. When you go over to that Lin-Reg t-test, you'll see X-list, the default should be L1, which is where we put our X values. Y-list, the default is L2, which is where we put our Y values. Frequency of 1, which is what we want. And then you'll also see the options for the test. So with the test, let me make the calculator bigger. We have to choose whether it's a less than, a greater than, or a not equal to. So in this case, we want to do the not equal to, right? That's what we're always testing for regression. And then you can scroll down to calculate and hit enter. When you do that, you'll get in our calculator y equals a plus bx. They'll tell you what test you did. They'll give you the test statistic, the p-value, the degrees of freedom, and then the a and the b values. So I have all that here as well, just in a slightly different order. So if we look at where everything's coming from, the a value, that 50.589, is where this 50.6 came from for the equation. And that b value, 1.16, is where that 1.2 came from. Now, your question was about making predictions. So if we look at this part B, that's where we're making a prediction. It says, given that the systolic blood pressure in the right arm is 90 mmHg, the best predicted blood pressure in the left arm is, and then we can see the right answer, 155.8 mmHg. So what we need to do is decide, are we going to use the equation, or are we going to use the average or the mean y value? We use the equation if we claim, based on that hypothesis test, that there is actually linear regression. So we'll use the equation if the p-value is smaller than that alpha level or that significance level. So let me see. So let me make the calculator big again so I can see the p-value. So over on the right-hand side here, they tell us that that p-value is about 0.072 if I round. So my p-value is about 0.072. And our alpha level, that significance level, was 0.05. So because the p-value is larger than the alpha, we cannot use that equation. So I can't just plug my number in for x. So now that's when I use that mean y value. So if the p-value is greater than alpha, like it is in our case, we just find the average or the mean y value. So I'll go back to my calculator. I need to get out of this Lin-Reg t-test, which it's not letting me do. Yay, technology, right? There we go. So I'll go to this calculator and I need to just find the mean. So remember, I do that by adding everything up. So I'll add up all the y values, the 175, 169, 145, 146, and 144. Then I divide by how many things there are. There's 5. So that's what gives us that 155.8.